Welcome back once again on this lecture series that is on the topic torsion that we're still handling. As I told you earlier on in the previous video that we're going to continue. Here is our second problem, and this is more advanced than the previous one that we did, but it is quite simple too. But please, before I continue, don't forget to subscribe to Adson Engineering Academy. This is where you learn your engineering what aspect, your doubts, everything is clear. So please subscribe, like, comment. Let's continue to this. The question is, a solid circular shaft transmit a power of 75 kilowatts. We have been given the power of P is equals to 75 kilowatts. But remember, putting it in a standard unit, that is what? So this will be 75 times 10 raised to power 3 in watts. Then at 200 revolution per minute, that means the number n of revolution is given to be 200 revolution power per minute. You ask to calculate the shaft diameter if the twist in the shaft is not to exceed 1 degree, meaning that our angle of twist must not exceed 1 degree. This is equivalent to, because this is degree, I have to convert it to radian, and it is equals to pi out of what? 180 in radians. So don't forget that. Yes, in 2 meter length of the shaft. So that means our L is given to be 2 meter, and that is the standard unit. Shear stress is limited to 50 meganewton per meter square. So that means our tau is given to be 50 meganewton per meter square. And mega in this case is the same as times 10 raised to power positive 6. So this is 50 times 10 raised to power positive 6. And then we have been limited that our G is equals to 100 giga newton per meter square. So this is equivalent to 100 times 10 raised to power 9. This is in newton per meter square. Remember, this is same as Pascal. So this one is also in newton per meter square. This is the information we have, and we are asked to calculate what? What's the question asking? We have to calculate the diameter of the shaft. From our torsional equation, where I said T out of J is equals to G theta out of L is equals to tau, that is shear stress, divided by the radius. In this case, we have two things. There is a combination of this one and this one. Then there is a combination of this one and this one. Two. All that can give us what? The diameter. Let's take the first one. If I take T out of J equals to G theta out of L, I don't know T. So I didn't explain for you how to get T, but I will let you know here to get T. In my situation, if I've not been given T, then I need a formula that will help me calculate what? T. So from that formula is power is omega T. But power is equals to omega, in this case is 2n pi out of 60, then times what? Times T. From this particular expression, I can get the value of T. What is my power? My power is 75 times 10 raised to power 3 is equals to 2 times n. N is the number of revolutions, and in this case it is given to be 200. Then times pi, I will divide it by what? By 60, and then you multiply everything here by T. When you make the value of T the subject, our T will come to, what is the answer in this case? When you press with your calculator very accurately, our answer is coming to approximately 3. That you need to confirm 3580.98. And you have to write this, whatever you have got, but you need to give the correct one, the correct unit. As I said in our first video, this is in Newton. We have now found the value of what? Of T. I can now substitute in any of these expressions so that I can come out with the value of what? Of D. So I can erase this part. You can recall it, can erase it. Alright, let's take the first one. It is T out of J is equals to G theta out of L. What's my T? My T is 3580.98. Right? Divide by J. In my first video, I explained to you how to get the value of J, which is pi r to the power 4 out of 2. But r is d by 2. R is what? Is d by 2. Don't forget that. Now, that means what I will put here? Pi divide by 2 times R is D by 2. But everything is raised to the power what? 4. Everything is equated to G, theta. What's my G? My G is 100 times 10 raised to power 9. And what about theta? Theta is 1 degree, which is pi out of 180. Then you're supposed to divide this by the length. My length is given as 2 meters. From this expression, you have to simplify it so that you come out with the value of what? Of D. What can I do in this case? Simplify just. If I take this one here, so this is 3580.98. Multiply this by what? By 2. I will divide it by this expression. I'll bring it down here. So I have here pi by 2, right? Then times 100 times 10 raised to power 9, right? Then times pi by 180. Everything here is equals to, when I take this one here, it is d to the power 4 out of 2 to the power 4. From this expression, that means I will take again this 2 to the power 4 here. I will get the value of what? Of d, which will give me, if you get the what? This expression d to the power 4. That means you're supposed to have 3580.98 times 2 to the power 4. Divide this thing by pi by 2 times 100 times 10 to the power 9 times pi by 180. Hope you can see this is equals to d to the power 4. That means if I take on both sides root of 1 by 4 here, then on this side also I do the same, root of what? 1 by 4 here. This will give me the expression for what? For finding the value of d. According to whatever I've got, my d is coming to, you can confirm that from your calculator, 0.0804. 0.0804 in meter. This is one way, but we have to take the other second option also, and we check whichever will give us the bigger value of d, then we take it. Let's continue. The first option is done. Then the second option is this. The second option is this. What is our t? Our t is 3580.98. Divide this by the same, which is what? Pi by 2, because we need the value for j. Then times r to the power 4, but r is d by 2. Raise this to the power what? 4. Then we equate this. We equate this to tau, which is shear stress. Shear stress in this case, we've been given that it is 50 times 10 to the power 6, because it is mega. And then we divide this by our r. R is the same as d by what? D by 2. You realize that this d to the power what? To the power 4 and d to the power 1 here will reduce to power 3. Then here will reduce to power 1. This is d to the power 1. It will cancel out. I remain here with the expression of d to the power 3 out of 2 to the power what? 3. Please do simplify this. You're going to come out with the value of d in a simplified manner with the expressions, and you confirm from your calculator it is giving us 0.0714. 0.0714 in meter. These are two different values of d. This one and then this one. Whichever is big, we take it as our final answer of d. Our d therefore is going to be 0.0804 in meters. This marks the end of this solution. It was kind of lengthy, but not very hard. Thank you so much for watching this, so that you get to learn more. In the next video still, we shall continue on this particular topic for more explanations. Please don't forget to subscribe to Hudson Engineering Academy. Thank you.